We'll now find the x and y intercepts of the graph of a function. The function is f of x equals the opposite of x squared plus 4x minus 1. A function will only go through the y-axis once, in one place, so there will only be one y-intercept. So let's start by finding the y-intercept. The y-intercept will be a number, or a point, and the first coordinate of the point, the x value, will always be 0. The second value will be the function value at 0, or f of 0. So let's find f of 0. That's the opposite of 0 squared plus 4 times 0 minus 1, which will give us 0 plus 0 minus 1, or negative 1. So that's the y-intercept. There can be many x-intercepts of a function. Any values of x that make f of x 0 will be x-intercepts. So any x-intercepts, whether they be none or 1 or 2, or however many, will have a second coordinate or a y value of 0. So in order to find the x-intercepts, we let f of x be 0 and we solve for x. Using the quadratic formula, we have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So x equals the opposite of 4 plus or minus the square root of 4 squared minus 4 times negative 1 times negative 1 all over 2 times negative 1. That gives us the opposite of 4 plus or minus the square root of 4 times negative 1 is positive 4. 16 minus 4 is 12. And all that's over negative 2. Now, we can simplify this by noticing that we can simplify the square root of 12 as 2 squared of 3. All that's divided by negative 2. And then let's factor out a negative 2. This will give us x equals negative 2 times 2. And it's still going to be plus or minus once we factor out a negative 2. Square root of 3 over negative 2. Negative 2 over negative 2 is 1. So we have x equals 2 plus or minus the square root of 3. That tells us that there are two x-intercepts. One of them is 2 plus the square root of 3, 0. And the other is 2 minus the square root of 3, 0.